Quideo 5 is on chapter 12 through 14, and we'll be talking about z-tests. The problem states, the drug AZT was the first drug that seemed effective in delaying the onset of AIDS. The subjects were 1,300 volunteers who were infected with HIV, the virus that causes AIDS, but did not yet have AIDS. The study assigned 435 of the subjects at random to take 500 milligrams of AZT each day and another 435 to take a placebo. At the end of the study, 38 of the placebo subjects and 17 of the AZT subjects had developed AIDS. We want to test the claim that taking AZT lowers the proportion of infected people who will develop AIDS in a given time period. So we're asked to state the hypothesis and check that you can safely use the Z procedure. We're also asked how significant is the evidence that AZT is effective, and was the experiment double-blind, and explain what this means. Our parameter is the effect of AZT on AIDS. Our null hypothesis is the proportion of those who developed AIDS after receiving the drug equals the proportion of those who develop AIDS after receiving the placebo. Our alternative hypothesis is the proportion of those who develop AIDS after receiving the drug is greater than the proportion of those who developed AIDS after receiving the placebo. So randomness is stated in the problem, and our NP is greater than 10, our NQ is also greater than 10. The sample size is at least 10 times the population. All of our assumptions are met, and we will proceed. The test we'll be performing is the two-proportion z-test. The equation we'll be using is z equals p hat 1 minus p hat 2 over the square root of p1 q1 over n1 plus p2 q2 over n2. Our p hat 1 is 38 over 435, which is the 38 people who developed AIDS while on the placebo, and our p hat 2 is 17 over 435, which is the proportion of those who developed AIDS after the drug. So then we plug it in, and our equation is z equals 0.08736 minus 0.03908 over the square root of 0.08736 times 0.91264 over 435 plus 0.03908 times 0.96092 over 434, and that equals 2.9403. So now we must obtain our p-value, and to do this we need to find our degree of freedom, which is n minus 1, which is also 435 minus 1, which equals 434. Our alpha is 0.01, and our p-value is 1 minus 0.9984 because in our alternative hypothesis it is stated that one proportion is greater than the other. So our p-value is 0.0016. We reject the hope that the proportion of those who develop AIDS after receiving the drug AZT is equal to the proportion of those who developed AIDS after receiving the placebo. So we reject the hope that the proportion of those who developed AIDS after receiving the drug AZT is equal to the proportion of those who developed AIDS after receiving the placebo based on a p-value of 0.0016, which is smaller than our alpha level of 0.01. To answer the question that was previously asked, the evidence that AZT is effective is significant at the 0.01 level with a p-value of 0.0016. This experiment was a double-blind experiment. This means that neither the subject nor the researcher knows who is getting which drug, the AZT or the placebo. This reduces the amount of bias in an experiment.